Okay, so 8:35, and today is January the 14th. So we are here. Um, we're going to continue talking about class definitions, and in terms of what is due, however, tutorial 1 is due this weekend. Tutorial 2 is technically due next weekend, next Saturday. I've extended that. I just haven't updated the. So if you check the server website, the date has been changed. I probably have to change it on Brightspace as well. But the calendars are just a bit of a pain to have to recompile them and stuff. So those may or may not get changed. But the official due date for tutorial 2 is next week. That's also right the same weekend as assignment 1 is due. So I mean, manage your time wisely. The tutorials are short, the assignment's a little bit longer. Just make sure you have time to do both. It's not really the length that's the bottleneck. It's usually like technical issues and bugs and challenges like that. Um, as far as test 1 goes, so I have sort of, uh, I haven't talked to the COMAS people yet, but I have gotten word that um, the, the, the funding is approved, right? So test 1 seems like it's going to be using COMAS. That seems very likely at this point. And because I haven't used COMAS before and I'm a little nervous about technical challenges, the last time I tried to use COMAS, it was a disaster. I've learned since then that simple is better, right? The more complex a thing is, the higher the probability that something's going to go, you know, drastically wrong. So we're going to keep it simple, and so hopefully it's going to work. But to that end, you know, test 1 might be a good test to show up for. It might be easier than because I want to keep it simple too. I don't want to make test 1 too complicated if we have to deal with technical issues at the same time. So it might be a little short. Might be a little simple, maybe. It will be code, mostly code, probably all code, possibly a few multiple choice as well, but I'm not 100% sure on whether that's a good idea or not. Um, so yeah, there'll be an assignment. You will come here, you'll set up your computer, you will download the code, follow the instructions to complete the code. You'll be able to, at that point, run it, and there'll be a few simple tests so you can sort of verify that things are working correctly, and then you zip it up and upload it to Brightspace. And then at the end of class, I guess I have to. Well, anyway, yeah. That's sort of the what you should expect for test 1 at this point. Again, as more information becomes available to me, I'll share it with you, but that is what I am reasonably sure of at this point. Do you need to download anything on your end? Yeah, you will need to download COMAS. But again, right, so I expect I'll hear from the COMAS people sometime next week, where they will give you, a set of instructions. So before the test, you should download COMAS and make sure that you can run it correctly. Make sure you bring your charging cable, right? Bring your computers. And then you will also have to download the starter code, right? So it'll be almost like an assignment, but a very simple assignment that you can complete in 80 minutes. So yeah, that is, again, that is what I know currently. And I'll definitely keep you guys up to date. I'm kind of excited. I think it should be fun, actually programming in class. And, you know, we'll talk more about it as it gets closer, but I will allow you to do things like ask TA's questions. Yeah. Yeah. If it,
Well, you just explained it was on, not on if it just fell and broke?
Yeah, I don't know. I'll probably have some paper backups. I mean, yeah, it's a real possibility. I'll ask the COMAS people what they would generally do in such a situation. Right? I'm sure there is a procedure. I'm not aware of it yet. As far as if it happens early, there'll be paper backups that you can write. If it happens late, then I don't know. We'll have to come to some other arrangement. Yeah, I don't know. That's a good question. I suppose that could happen, but so we'll come up with some sort of procedure for that. Other questions? Yeah,
Yes.
you can if you like. You can use basically whatever you like. Yeah, just turn it off, and yeah, make sure it's turned off because the primary way to determine if you're cheating is going to be screenshots, and so if you have VS Code, I can see if it's enabled or not, right? So make sure it's disabled. And if something goes wrong, yeah. Yeah, that's fine. I don't mind that. Yeah, I just want to stay away from large language models because, these are sort of simple programs I'm asking you to write, and a large language model can do it, no problem. So, yeah. Other questions? Yeah.
Like studying.
Uh, no. I'll give you a practice test that'll have some very similar coding questions. There'll be a few like distractor things right? So the practice version will be more complex than you'll likely see on test day. And if you could do that, like if you could sit down and code that up in say like an hour or two, then you should be fine. Also, the assignment, it's going to be very similar to the assignment, but with like less application logic. Like in the assignment, you have to do things like make sure two reservations don't overlap. Probably we won't get, right? That's a good challenge for an assignment, but not so great on a test because it's something you can easily mess up and then waste all your time on and then not finish the rest of the test. So yeah, it'll be a simplified version of assignment one. Other questions? All right. So last class we were talking about class definitions. And so just a short review, we were talking about writing code in C with just functions and structs. And then we converted that to C++ with classes. And so the idea is that, well, functionally, these things are the same. They're just sort of structured differently, right? So C only has global functions. C++ has member functions. So I can take a struct, which is really just a piece of data, and I can have functions that are associated with that struct. And so in some sense, they go everywhere that struct goes. And that's basically it, but that gives us a bunch of other things. That gives us encapsulation, right? So now we have access modifiers that we can apply. And then sort of hide. So we have a student class, and our student class has a bunch of, let's see. Right, our student class has a bunch, not here, sorry, of member variables, but they're all private now. And that's called encapsulation, where I sort of hide and or disable your ability to modify these pieces of data, except through functions that I approve of, right? So I give you some public functions, which is like an interface, and then you call those public functions, and that is sort of, you cannot change the data directly. You can just basically request that data gets changed through the public functions. And I can make sure that if you try to change the data, that you do so properly, right? So it's this, by rearranging our code a little bit, it compiles into the same thing, but now we have, encapsulation basically, which is one of the things that we need in order to make modular code, which is going to help us make bigger programs with subsystems that talk to each other. So that is more or less where we left off last class. So the idea is behind object-oriented programming, behind objects in general, is this idea of encapsulation and, more generally message passing, or not message passing, but if I call a function, that's a request, right? When I implement the function, I don't actually have to, you're asking to change a piece of data, I don't actually have to do it unless I want to. So all of my functions decide when and if data is modified. Entities outside the object can only request data to be changed, and this sort of, now we've set ourselves up so that we can have subsystems in larger applications. And that brings us to access modifiers, right? So public, protected, and private. Again, I might be reviewing some stuff. I have 3 lectures, and I confuse some of these classes. I think we did this already, but I'll go over it quickly. So public access, everybody can access, right? So whether it's a variable or a function, if it's public, anybody can call it from anywhere. If it's protected, whether it's a variable or a function, well, in C++, that means that, well, protected is inheritance, right? So my children, my derived classes, can access those members. No one else can. And private access means only my class can access them. But also other members of my class can access them. So a student can access another student's private member variables, but a university cannot, for instance. All right, so when we make a class, the syntax is, well, we use the class keyword followed by a block, right? So open brace, close brace. And then there's a semicolon, right? So technically when I declare a class, it's like a statement and I have to end it. So that semicolon is, sort of a source of bugs. If you forget it, inside my class blocks are the class members. I can declare data members or functions. And I can use the access specifiers to sort of divide up, public blocks or a set of public functions from a set of private functions, right? And I don't use blocks per se. We use, we just declare the start of a public section with a semicolon, and then we put all our public members below it. And then if we want to start a new block with a different access modifier, we just write that new access modifier, right? So it's not, they behave sort of like blocks, but they're not really. And I think this is where we left off, actually. So classes, you can think of them as structs or objects or whatever you like. But when we declare them in C++, the same as we do with primitives, we have a choice about where to declare them, right? So if we look at this, you see that there is no new keyword here. I've simply declared the type and the name of the variable. So in this case, Casey is a student. But Casey also has, or student also has a constructor that takes 2 arguments. So when I declare my student Casey, if I want to call this 2-argument constructor, I'm going to supply the parameters right there. And if I don't want to call a constructor, or sorry, if I want to call the default constructor, right? So every time you make a class, a constructor gets called, whether it's the default one or whether it's a default one that you've made, or whether it has certain arguments. But if you're calling a no argument constructor, then you don't put any parentheses, right? So that's, again, that's a little bit different from Java. In Java, if I had a student, I would do something like this. Student stu equals new student. And then I would have the parentheses. Whereas in C++, I would do something like that. All right, so we will talk about statically allocated and dynamically allocated. And for your assignment, you should be using statically allocated objects, right? So we're going to start with that, and then we'll move on to dynamically allocated. In In this case, when we say statically allocated, we largely mean on the stack. Of course, that's not the complete story because we could statically allocate a variable within a class declaration, for instance. But for the most part, when we say statically allocated, we mean we're putting it on the function call stack somewhere. So in this case, if I do that inside of a function, these objects are allocated on the function call stack. And when that stack frame is popped off, in other words, when I return from that function, these two objects are destroyed. All right. So it's important to understand the lifetime of these things. We'll get into that a little bit later. Also, though, when we declare an object, we can allocate it on the heap. So in this case, I use the new keyword, and new always means heap, right? So statically allocated means it's allocated within the context. New means it goes on the heap and you get a pointer back. Always, no matter where I use this syntax. All right, so the heap is slower to allocate objects, but the objects last as long as we like. Again, for assignment 1, we're sticking with the stack. We shouldn't be using the heap at all. But we will mention it because it's going to come up for assignment 2. Typically, a class in C++ is divided into 2 files, a header file and a source file, in this case, a .cc file. Usually they're called .cpp. We use .cc because, well, I'm not exactly sure. Because Christina started doing it and I kind of liked it. I think it gives us our own flavor. So .cc for this class is the source. Now here, I declared my class student and I made, a constructor and a print function and an isPassing function. And I put all of the implementations with the class. And that's perfectly legal, perfectly valid C++. For larger classes, this is not recommended, right? It's recommended that you separate them out, the source from the header, so that when we compile, we can compile our classes individually, right? If it's big, I don't want to recompile this class every single time I recompile my application. I only want to recompile this class if I change the actual class. So this is valid, but we're going to show you a sort of, I guess, better way to do things. All right, yeah. Let's just jump into. So we're going to take this student class and we're going to yeah, so here we have another version of the student class. Here the member variables are at the top. And so this is the same code that we ran before. Let's just make sure that it works and then we will modify it. Yeah, sorry. Making sure it's in the right place. Permission denied, right. Okay. So I have I initialized 3 students and I printed them out and there they are. And then I printed out all the passing students, there they are. And I did that just by declaring the student class before this. So now we're just going to change the structure of it into something more suitable, right? And for starters, we're going to have a header file for my student class. So I'm going to take all of this code, hopefully, and remove it from there. And I'm going to put it here in the header file. And then so that the compiler still knows what a student class is, I'm going to include that header file, right? So at this point, functionally nothing, absolutely nothing has changed. When the compiler reads this, when it sees include student.h, it jumps over, continues reading. And so this will compile exactly the same as it did before. But now we're going to change it a little more because I don't want these implementations here. I just want the declaration. So yeah, let's start from scratch. So what do I want in my student class? Well, I have my private member variables, and then on top of that, I want a constructor, but I want a no argument constructor, right? So I write one in and just the definition. And then I also want a 3-argument constructor with name, or 4-argument. And again, just the declaration. I want an is passing function. And I want, what was the other one? A print. And might have been it, eh? All right. So there we go. In my header file, I have just the class definition. So I have my member variables and all of the functions that are going to be used. And again, well, I'm going to add one more thing here. I'm going to add some header guards. Sorry. I'll explain what these do in a second. So these, well, I'll explain what they do, but then I'll give you a demonstration. These protect you against multiple includes, right? So if I had a student class that I want to use and I have a header file, I might need to include that definition in multiple compilation units, right? So I might need it in my university class, and I also might need it in my main.cc. And so what can happen is that, well, if I include university in main.cc and university includes student and main also includes student, well, this might get read twice, right? This student class definition might get read twice by the compiler, and that's actually the compiler being dumb, right? Doesn't realize that it's supposed to be the same student class and says, well, you've tried to redefine student, and so it won't compile. So these header guards protect us against that. So if a compiler reads this once, it says if this student underscore h is not defined, then define it. And then continue reading down here until we reach the end diff, right? So the first time the compiler reads this, it will read through it. If it happens to read through it again, it's going to say if not defined student underscore h, and then it's going to remember, no, actually that is defined. I already looked at this and I saw student underscore h, and so it's going to skip the rest of this, right? So header guards ensure that your class headers only get read at most once. All right, so now when I want to compile this, I have a class definition. I don't have the code yet, but that's enough. I can't make a I can't make an executable, but I can make an object file, right? So an object file is, again, I made some function calls and whatnot, and the compiler can see the functions and see if I use them correctly, but it doesn't have the source code yet. So we're going to give it the source code. Questions so far? All right. Okay, so in my student.cc, well, the first thing I want is actually the definition of my student class, and then I'm going to give you the implementations. So let's start with the no argument constructor. However, if I write it like this, the compiler doesn't know that this is a member of the student class, right? So it sees a student class, and it sees that it has a constructor that looks like this, but the compiler needs an extra hint here. So I'm going to use the scope resolution operator to tell the compiler that, right? So in this case, student is a class, but you can also think of it as a namespace, like the standard namespace. And so what I'm saying is that this student constructor in this case belongs to the student class. All right, so what that means is that this tells the compiler like, oh, all member variables and functions I can call from inside this function. So yeah, now name equals unknown. I'm just going to give some default values. Number. Okay, so there's our no argument constructor. So now we can give our for argument constructor. Again, we're going to scope it in. We're going to tell the compiler that this is part of the student class. All right, so I'm doing a few things here. Right, I'm using the this keyword, and I'm using it because I have a naming collision. Right, so let's just change this to G. So name, number, major. If I look at student.h, oh, it's student number. And that's going to be an error. Let's just change this to number. So name, number, and major, right? Those are parameter names, but they're also the member names. So I have to tell the compiler, you know, that, hey, this, if I use the word this is a pointer to my current student. And so if I say this name, that means grab the member variable from the student class. Don't use this parameter. And then here, when I don't qualify it with this, that means use a parameter, right? So hopefully that's review. I believe you do similar things in Java. But this is essentially a pointer to the current object. Now, if I don't have a naming collision, if I named my parameter something different, so G instead of GPA, well, then I don't need to use this. If I say GPA, the compiler has only one version of GPA, so it can go find it, right? So in this case, name is being shadowed by name, but I can still qualify it as this name. All right, so we also need a isPassing function. And GPA greater than or equal to 6.0. And a print. Well, let's actually, so what happens if I forget to use the scope resolution operator and tell the compiler that this belongs to the student class? Well, let's go over here and just out of pure laziness, I'm going to copy and paste this over here. But all right, so at this point, I have sort of defined every single function that's in my header file. And so I want to compile the student class. And to do that, this should work, right? Yep.
Or you just use print. I'm
What do you, sorry, what do you
like
mean?
let's say you said like using this, right? The this operator.
Yeah.
And like is print something that does that instead? Or is it just a function?
Yeah. Well, I did something wrong on purpose here, so I'm not sure if that's what you're getting at. Like I didn't put the scope resolution operator. So yeah, what's going to happen? Well, let's try and compile it and see. Maybe this will answer your question. I'm not sure. If not, let me know. Oh, yeah, really? Um, Right, it's empty. Why is it empty? Am I in the wrong spot? Or did I not save it? I might be in the wrong. We're section B, right? And this is C. All right, so I'm in the wrong spot. Sorry. All right, we'll just swap sections B and C for today. Okay, so at this point, first I'm going to recompile p1.cc. Right, so again, that's p1.o, but I have the function definition. It's not complete. And then I'm going to try and do the same thing for student.cc. Whoops. Okay, so it's got a bunch of errors here. Name was not declared in the scope. Oh yeah. Because this is uh, oh, well, I mean, this is a good opportunity. Anybody spot the error? So in file included from student.cc, string does not name it. Well, I guess. So whenever you see a long chain of errors, probably the error you're most interested in is at the top, right? Because what happens is that string does not name a type. So I forgot to include the string library. But that led to a bunch of other errors since it doesn't understand what string is. Now all of a sudden it also doesn't know what name is. And so in C++ you can get these really long error outputs. And what you should really do is look at the first one. And that's going to be the biggest hint as to what went wrong, generally speaking. But yeah, I want to include the string library. I probably don't need IOStream here, but just for fun, just to keep our life simple, I'm going to include that because I know I'm going to need it in student.cc. All right. And yeah. Okay, that's better. I mean, I have a different error now. So I've included all the libraries, I've scoped in the namespace, I've done everything I need to do to syntactically dial all that in. Uh, no, that's not the error. All right, sorry, I got to track down. Apparently I'm doing multiple things wrong, not the least of which is okay, and then okay, here's where we want to be. All right, so sorry about that. If I happen to forget the scope resolution operator, right? So in student.cc, I defined these two constructors, this function, and then I have print, but I forgot to put student : here. And so when that compiles, what the compiler sees here, like this is still semi-valid syntax, right? The compiler looks at this and says, oh, you want a global function called print that does a bunch of stuff. So, I mean, up to here, this is fine. But when I add these in, now the compiler is confused because it doesn't know what a name is or a number is or a major or a GPA. I've not declared those variables in this context, right? So global function, fine, but these member variables are now confusing the compiler. So I'm going to tell the compiler, actually, this belongs to the student class, and then it'll be able to identify those member variables. All right, so what did we do? We had a definition of a student class here, but we've taken it out now. We've divided it between student.h and student.cc. In student.h is just the declaration. So it's the, right, the keyword class followed by the name, followed by, well, in this case, member variables at the top, because that was, I believe that was generated with Copilot, and Copilot likes to do that. And then the declaration of all the functions that are in this class, but I leave the implementations out, right? And then this is enough for the compiler to say, well, you know, I called the student constructor here, and the compiler can verify, yes, a student constructor with this signature exists. I call print, and the compiler can verify, yes, this print function exists. And I call isPassing, and the compiler can also verify that, right? So that's enough to compile this on its own. And then over here, we put all the definitions, and we compile this into student.o. And so now we have p1.o, which is an object file for the main class, or sorry, the main function, and student.o, which is all of the implementations of our student class. So now we can link those together. P1.o. And then when I run it, I get basically the same thing I had before. I print out all my students. Well, there's 3 of them. The formatting is terrible, but and then I print out all the passing students, and there we go. All right, so that's the structure when you write your assignment and start making classes. Your classes should be divided into header files and source files. And then when you compile them, right, if we jump into the make file here, no, I don't need the all, I need this. Well, now I'm going to compile and link this student object file separately. All right. All right, so student gets compiled into an object file, and my main function also gets compiled into an object file, and then up here I link them both into an executable. And if I had more classes, I would simply list them using this same sort of format, right? So if I had, let's say, a university that the student was attending, and that was its own class, well, I can just do this, which will, you know, it's basically the same for every class. I want to compile university.cc into university.o. And then up here, I would link it. I would add it. I cannot spell today for some reason. Unit, yeah, all right, whatever. All right, and yeah, sorry, student.o should be here too. Okay, so make files for our you know, assignments and or tests are going to be very straightforward. Every class is compiled into its own object file. And then if I have a main, right, main.cc with a main function, I will compile that into its own object file. Or, you know, if you skip that step, that's probably okay. And then finally, I will link all of those object files together into an executable. Okay, so that's what your assignment should look like, for the whole semester, I guess. Questions? Okay. All right, so yeah, we divided into a header file and a source file. Yes, yeah, you're right. Actually, it might matter, eh? If I tried to run this univ, just in case. So yeah, well, let's. Still mess up that, eh? University. No, I didn't save it. Oh yeah, well, I don't have a university class, so this is kind of a waste of time. I do have one later. Um, all right, and I think I need to update my clean step. No, that's actually okay. All right, so yeah, everything works now. All right, so in the header file goes all of the function declarations. In the source file, the .cc, we would do something like this. We're going to do the implementations, but we're going to tell the compiler that it's part of the student class. And then when we do that, the compiler will recognize these as member variables. You can, right? It still works if you include the implementation in the header file. For example, let's say, I mean, this is a rather simple function. So let's say instead of putting it in here, I decided to put that in the header. That may or may not be a great idea, but it's certainly valid. So I can include like short functions in my header file. And for things like getters and setters, that's probably a good idea because what it does is like here. You might be right. That does not, I don't think so though. No. I'm getting a lot of fumbling around with errors a lot today. So what would be the problem? GPA is correct. Oh, I must have, I know what it is. So here, I mean, I guess another good example of sort of the weird things that can happen when you compile things separately. So when I recompiled this, I just hit make. No, it recompiled student. All right, well, when in doubt, do a clean step. And there we go. All right, so some old piece of object file somewhere had incorrectly, trying to think of what could have actually happened there. So I'm not sure exactly what happened, but basically I have like a stale object file, and that object file had a definition of is passing when it shouldn't. So it either redefined it or it was missing a definition, but so a clean step will fix that. Good grief. So many bugs today. Okay, so yeah. Getters, for example, it's actually kind of a good idea, and you can use the inline keyword to sort of, I mean, you don't need to know this per se, but It helps make things more efficient, right? So a getter, if I try to inline it when it's compiled, instead of calling a get function, it will simply take the code inside the function and, in some sense, copy and paste it in place of the function itself, right? So that's called inlining, and that means that it speeds up my code because I don't actually make that function call, but functionally, it's the same thing. But yeah, for the most part, though, we want to keep the implementation separate. That helps with encapsulation and the principle of least privilege. We don't want to necessarily give away our source code. And if we do, even if it's open source, well, sort of, letting the user in on the implementation can sort of lead to them relying on that implementation, and that means that I can no longer change that implementation, right? So that's known as like a leaky abstraction. We'll get into that later. All right, so standard member functions of our classes. So all classes should have a constructor. If you do not provide a constructor, you get a default constructor. But the job of a constructor is to initialize all data members. There are a few ways to do this. We're going to later see member initializer syntax, which is more efficient. But for now, we're just going to use inside the body of the constructor, we can use assignment operators, right? That's fine for what we're doing for now. We can provide multiple constructors. So if we have a constructor with no arguments, that's called the default constructor, and that can get called implicitly for things like arrays. So we get to decide if there's a default constructor, right? So if I don't provide any constructor at all, then there's a default constructor. It doesn't do anything, but you are allowed to make an instance of a class that has no constructor. If you provide a constructor, say a 3-argument constructor, well, now your default constructor gets deleted, okay? So you no longer have access to the sort of freely provided default constructor, but you can still make one. So we get to decide if a default constructor exists or not. The syntax, we can have multiple constructors, and actually they can call each other. We're going to see the syntax later. It's not like Java where we have this super keyword. In fact, it's, that's, yeah. You can use super to call other constructors or to call like base class constructors, but in C++, we just use a different syntax. Okay. Other standard functions, there's no toString function in C++, right? This is, for every object in Java, you have this toString function. For us, we're going to initially just use print functions, and these will print to the standard output. Later, we'll see how to overload this stream insertion operator, and then this sort of becomes our toString equivalent. And yeah, so the body of the functions, this is just the example we just did where we separated out the header and the source file. All right, so on the topic of allocating variables and where they are, but specifically with reference to arrays, we'll look at this next example. So here we have a date class, right? So we have our header guards, we have all our libraries, and the standard namespace is scoped in. We have our regular constructor. We have a no argument constructor. We have a copy constructor, which we don't really need. Let's get rid of that. We'll get to copy constructors later. So we have 2 constructors, 3-argument and a default, and then a bunch of setters. And basically, it's very simple. We initialize day, month, and year, and then we can print it out, right? So this class doesn't do very much. And over here is the implementations. And inside the setters, of course, we do some data sanitization. So we make sure that the day is valid, so we're going to check which month get max day, checks which month it is, and then you can figure out how many days in that month, and then you can see if D is a valid number. And of course, a month must be between 1 and 12, and the year will say that we go back as far as 1901, but no further. All right. Okay, so that's our date class, and we have our main function. So we compile main.cc into main.o and date.cc into date.o, and then we link them both together for this executable. And so, yeah, we will make our two dates. One more thing is inside the constructors, we declare which constructor we've called, right? So we want to see when these constructors get called, when we call the 3-argument constructor and when we call the no-argument constructor. And then here we make two dates, and one calls the, one has 3 arguments and one has no arguments. And so, well, we can imagine what will happen, but let's verify. So yes, a 3-argument constructor was called and a no-argument constructor was called. So for D1, we have the 3-argument constructor. For D2, the no-argument constructor. And all right, so let's print them both out. And there we go. D1 is September 9th, 2020. And D2, well, it had all default arguments. By default, we set it to January 1st, 1901. All right. But on your assignment, you're expected to use arrays. And a special kind of array, a statically allocated array of objects. All right, so this is sort of the sort of declaration that you would use in assignment 1, not necessarily with the date class, right? For you, this would be an array of reservations or an array of, I forget what I called them, some rental units or whatever they are. So let's see what happens when we declare that. And you can see that 3 default constructors were called, right? And our array has a size of 3. So max size is 3. So what happens when we make an array Okay. So in our main function, we call our main function that we have a stack frame that goes on the stack. And then we declare this array of size 3. And so on the stack, we get an array of size 3. And inside each of these is a date object. And so every time we create a new date, we have to call a constructor. So in this case, for every single element in this array, the default constructor was called. Okay, so this is important because this is exactly what I asked you to do on assignment 1, which means that for each of the classes that I ask you to do this for, you're going to need a default constructor. All right. If I don't have a default constructor, if I, for instance, comment these out, well, then the compiler gets confused, right? So you can see here, this is the source of the error. I declare this, but it says, well, I can't really find a constructor that would help me construct these date objects, right? In other words, all the constructors I can find have arguments in them. So yeah, if you don't have a default constructor, you will not be able to make an array of objects as you're asked to do. Questions? Okay. There are ways around that, but, right, so this is an array of size 3. I can just simply pass in, this is a temporary object, but the compiler is going to do some behind the scenes optimizations, and this is just going to call the constructor on each of these memory locations in my array and provide those arguments. So this will actually work. That's fine if your array has size 3. If your array has size 100 or 256 or whatever it is on the assignment, this is not going to be very easy to do, right? So the recommended way is make a default constructor and then just declare your array like that. Once we do that, oh yeah, I need it. Right, so the default constructor is called, and then I print out all the dates in the array, and they all have the default arguments. So then at that point, I have to come up with a different way to set them. Well, in this case, I can call the setters. And then print them out. So that works. There is another way to do this. If I don't have this setter, I can do something like this. Now this is, because I am asking you to statically allocate all these things, it means we're going to do sort of a roundabout way of initializing them. So if, for example, I had an array of reservations, as you would have in your assignment, and I wanted to make a reservation and assign it to a location in an array, this is one way to do it. All right, so this is going to make a temporary date object. It's going to copy that temporary date object into the array, and then this date object is going to get destroyed, which is not super efficient, but for our assignment, this will be fine. Okay, so let's make sure that this works. And yeah, you can see that, well, here, when I made those two assignments, the 3-argument constructors were called. When I printed out my array, now those 2 locations had those dates in them. All right, so this is, again, for the purposes of assignment 1, this is a valid way to initialize your array locations. Questions? Okay. All right, so this is just a little note on header guards, right? So for, well, I don't have a good example. When I get a good example, I'll show it to you. But if ever you get these problems where, you know, a compiler doesn't understand a definition and or you define something multiple times, but you really didn't, but the compiler thinks that you did, well, then you should, when you're debugging this sort of thing, you should think like a compiler. And our compiler is just dumb and does not do anything special, does not do multiple passes. It just starts reading, right? So if I'm thinking about, if I have an error with this command, well, then I should start thinking like a compiler and I should start reading date.cc. At the top of date.cc, it has date.h. So I'm going to jump over to that file. I'm going to keep reading. And then you should consider, right, am I reading anything twice when I do this? Am I including something in date.h? Maybe that is a circular reference. So that is one way to, you know, just some advice for debugging when you get these types of errors, which you will start to get. All right, class interfaces. So a class interface in C++ or in any programming language, interface means something, it's not exactly a Java interface, right? Java interface is an official construct, but an interface in general is just whatever part of your class is publicly facing. Class, library, subsystem, whatever. So public facing means what are the publicly available functions? What are the publicly available data types? This composes your interface. So for a class, all of my public class my class name and all of my public members, right? So if I have a public member variable, that's part of my public interface. If I have public functions, those are part of my public interface. And the public interface is basically how users will interact with your class. The private stuff they can't access. That's just for me to use. So typically in C++, this is containing your header file, although, so C++ is trying to move to modules because, of course, a header file also exposes what your private member variables are, which is a little bit of a problem, but you know, for us, it'll be fine. So to use my class now, right? So if I'm a user of a class, I take the header file, I include it in my program. It contains the public interface and enough information for the compiler to see that I use the class correctly. It also has information, right? Like it might have some documentation on how to use a function. It's exactly like I have a forward reference to all these functions when I include this header file. Then I compile my code, and then I link the object code to my implementation. So what we get now is something like this, right? So I develop a class, I have a header, and then I have a source file. And I include the header in the source file, and I compile it, and I get this object code. And then somebody wants to use my class, well, I give them the header, they include that in their main, they compile their main, and they get an object file, and then I give them also the .o file, and then they can link that into an executable. And this stays with me. I don't have to share it with them. Right? So that's important if you're, for instance, if your source code is proprietary, right? If people are supposed to pay money for it, then I don't want to give it away for free. But this is also, helps with the principle of least privilege, where I don't necessarily want to give away what my implementation is, because if I do, then users are going to start depending on it, and that means I can't change it. Right? So we want to keep our code flexible for change. The other nice thing is if I have a bug in my library, well, I modify the source code, I recompile it, and then I send it out to all of my users. And then the users just are going to relink it, which is fast, right? So that's a nice fast update. So you'll notice, right, when you update your code, that's a lot faster than, well, it happens really quickly in a couple seconds, right? So you have applications on your phone or whatever, and updating them is fast because generally speaking, you're just linking, you're not compiling anything. You're getting machine language or, well, I mean, it depends on the platform, of course, but, assuming you're using C++, you're getting an object file, and then you're just relinking it to your source code. So yeah. So who's using our class? Mostly other developers. So other developers, what they need to know is your class name. They need to know the public members, what they're allowed to use. Probably some descriptions, right? Some documentations. And then and sometimes they need to know about protected members. They don't really need to know about private members, but they kind of get those in the bargain. Yeah, and the header guards. All right, so in general, your source code should include your header file, not vice versa. And basically, anybody that uses your class is going to include the header file and just link the source code later. All right. Yeah, let's jump to a woo clap. All right, so this is reviewing some of the stuff that we just learned, but a lot of it through the lens of memory. Okay, so what describes the principle of least privilege as it applies to classes, right? So one of the reasons why we prefer classes over structs, at least for this class, is because they sort of carry this philosophy of the principle of least privilege. But what does that mean? So all members, variables, and functions should be made private whenever possible. Member functions should be public. Yeah, so number one is the correct answer. Basically, everything that you don't need to know about as the user should be private, right? So everything is private by default, and I just expose only the things that are absolutely necessary to expose. All right, so here's a bunch of memory stuff. So where in memory is this student going to be stored? A lot of you said the stack, and that is correct, right? So this is statically allocated, and how we know that is there is no new keyword there. And since we declared it inside this foo function, when we call foo, that student will go on the function call stack. All right, so here's a bit of a different syntax. So we only sort of briefly touched on dynamic memory, but hopefully you remember enough details. So where would this student object be? And yeah, so I am fooling absolutely nobody. Everybody guesses the heap, more or less. And yeah, that's correct. As soon as you see new, you know that it's on the heap, always, no matter what context you declare that in. Now we have something a little bit trickier. We haven't taken composition yet. But yeah, see if you can sort of surmise or take an educated guess as to where this student stu would be stored. Right, so assume I have this class university, I declare stu, and then I declare a university in the main function. So where is stu going to be stored? So the code segment. Really, you guys are just guessing. The function call stack is correct. Why the function call stack? Well, if we briefly look at what is happening, so when I define university this way, if I look, right, you can think of it as in terms of structs. What happens when a struct contains another struct? Well, I simply have a struct called university, and inside that is a struct called stu, and these are stored together in memory, right? And essentially, yeah, I'm not even sure how much memory this would take up, if anything, but assuming there was some useful information in stu, then basically stu would, maybe there's a name, a student number, GPA, whatever. So this is a student that is statically allocated within a university, and this university is on the function call stack. So stu would be on the function call stack within the university. All right, something a little bit trickier. Where in memory is stu? Assuming that stu is a student object, I guess. Well, this is a little bit ambiguous, I suppose. So in this case, stu is a pointer. But consider, well, if we had a student object, where would it be stored? I guess this is really not worded well. But yeah, we can talk about what what ultimately this means. So yeah, the heap, the function call stack, there's no student object created is technically the correct thing, but that's not, right? So this question is worded poorly because stu is a pointer, and the pointer itself is stored on the function call stack. If I had a student object, if I initialize this, that student object would, well, it could be anywhere, right? I can point a pointer to a student on the stack or on the heap, but there's no new keyword here, so currently there's nothing on the heap. This student pointer is on the stack. Yeah.
Have multiple this. There no student object be like the correct answer.
Yeah, it would be the correct answer. But I'm just saying that this actually doesn't ask where the student object is stored. So it's poorly phrased, that's all. Stu is a pointer. So if I said, where in memory is stu stored? Well, technically that's asking where is this pointer stored? That pointer would be on the stack. But also, this is also correct. There is no student object created. So either of those, if that actually came up and I made that mistake, you just sort of give points for either of those answers. All right, so there we go. Woo clap number 2 in the books. Questions? All right. All right, so let's talk a little bit about scope. This applies to your tutorial 2 now, which I think 10 minutes we might be able to get to. So we actually have talked about variable scope, but we're going to look at one more sort of angle on this scope issue. So we've seen block scope. That also includes class blocks. We've seen variables at file scope, so those are global variables outside of any block. There's also these types of scope, which we're not really going to look at in detail, right? So you can use labels in C++. We're not going to cover them. And you do have, sort of parameter scope for a function call. So this n can be used over here. We're not really going to look at that either. But one of the things about scope is that we can use namespaces to help resolve these scoping issues, right? So we've seen examples where we had an X defined in multiple scopes. And as soon as I declare an X in a scope, an inner scope, it hides the X in the outer scope. And so those X's are no longer visible at all unless they are global variables. But we're going to look at one more thing about variable scope, which is what happens if I want to access a global variable from another file. And then we'll move on to namespaces. So yeah, this is an example that you've mostly seen before. So okay, so I declare a global variable, and then I access that global variable, and then I shadow that global variable, but I can still access it using the scope resolution operator. Right, so the global name is William Bonney, and then Elias shadows that name, but since this is still a global variable, I can always access it. But the issue is, what if this was in another file, right? So when I have a function that's in another file, I just put a forward reference. I put the function prototype, and that tells the compiler, look, there's this function, it exists. I didn't give you the definition yet, but trust me, I'll give you the definition later. And so what if we had to do the same thing for a variable? So in this case, I want to use a name that's defined over here, Billy the Kid, right? So this is a global variable, so I should have access to it through my whole program, but I'm going to compile this separately and then link this to my p3scope.cc file. right? So what happens in that? How do we forward reference this this variable? Well, typically, if it was a function, we would just give the function definition. But if I do this, I've actually declared a variable, right? So this is not correct, or rather, if it was correct, it would be ambiguous. Am I declaring a variable called name, or am I forward referencing it? So in order to help out the compiler, we use the extern keyword. And what that means is that essentially it means this is an external global variable. But what I'm really saying is that I'm forward referencing, I'm declaring this variable, but I'm not like declaring it. I'm saying it exists somewhere else. And then I can reference it through another file. All right, so I can no longer, for example, right, so if I wanted to compile it, so now when I try to compile it directly into an executable, it doesn't work because I've declared this external string variable and it can't find it, or name variable, right? So what I can do is compile that into an object file, and then I can compile ext.cc into its own object file. .cc. And then I can link them together. And then I can safely run my program, and now I have this global variable, Billy the kid, that is contained in another file. All right, questions? Okay. 3 minutes left, eh? All right, so we'll introduce namespaces. We don't really have time to get into them today. That is, sort of namespaces are what your tutorial 2 is based on. So, we'll cover it early next week. But, try it out. They're not that difficult to use. And in fact, they're quite intuitive. But basically what we want to do is we want to resolve naming collisions, right, I have a library, I might put it in its own namespace, right? So I can't remember if I did that on assignment 1 or not. But in addition to namespaces, there are unnamed namespaces. So for example, yeah, so here I have, let's say I'm defining a gaming store, a video game store, and I have some employees. I define these as global variables. I can use them now in my main function. But let's say now that I want to have a second branch of employees. Well, I can do that. So I can redefine these 3 variables. And then, I don't know. Right. So now I've declared manager, cashier, and stock person, and manager and cashier and stock person, but I won't have a naming collision because these are in a different namespace. Right. So yeah, I think my make file is not properly made. All right, that's just don't do that. That's just a hack to get rid of that error. But yeah, so here we have our 3 global variables. And then we've also defined a Orleans namespace. But next week, we will see how all of that goes together. And It's not that difficult. So, give it a try on your assignment. Basically, we're going to use the scope resolution operator, or you can scope it in using the using namespace, whatever. So either of those are valid ways to sort of get around this naming stuff, but yeah, we'll do that next week. So for Saturday, please get your tutorial 1 in, and yeah, that should be it for this week. So yeah, that's it for today. I'll see you next week, or tomorrow I have my office hours at 10:30, right? So ish. I have class till 10, and then I like to pick up a coffee on the way back. So 10:30 is a safe time. It says till 12, but like I can extend that if anybody needs it. Just let me know.